Rocket Lab is launching the first ever private mission to Venus. Europe is considering space-based solar power, an awesome new method to detect exoplanets by their magnetospheres. More evidence about the moon's origins, Webb's largest ever image. All this and more in this week's episode of Space Bites. Hi everyone, I'm Fraser Cain. I'm the publisher of Universe Today. I've been a space and astronomy journalist for over 20 years. This is our Space Bites episode, where we give you small, bite-sized versions of a lot of the stories that we're covering on Universe Today. Now, this is just a short version of my weekly email newsletter, but we understand some of you prefer video over text, so let's get into the news. Rocket Lab wants to send a mission to Venus. Poor Venus. It's chronically underexplored. Of course, this is our evil twin planet with almost the same mass as the Earth, with a thick, hellish atmosphere, temperatures that would melt lead. It's a terrible place to try and explore on the surface. But in the upper atmosphere, things cool down, and at the right altitude, you can actually get the same temperature and pressure as the Earth's atmosphere. And it seems like it could be a place where there might be life. And astronomers think they might have found chemicals that could be associated with life. I know there's a lot of like could and should and maybe, but anyway, and this was of course that discovery of phosphine a couple of years ago. Now, whether or not there's actually phosphine in the atmosphere of Venus is a bit of a controversy, and so the best thing to do is to go and check. Now, there's an idea for a mission in the works from Sarah Seeger and a bunch of other astrobiologists on how you could search for phosphine and maybe other evidence of life in the cloud tops of Venus by actually going through the clouds of Venus. But who's going to send this mission? Rocket Lab announced this week that they are going to fund a rocket to Venus to send a payload capable of performing these experiments into the atmosphere of Venus. So if all goes well, the rocket will launch in 2023, fly into the cloud tops of Venus, and try to sample the chemicals all around it. And hopefully at that close distance, it should be able to give some kind of conclusive evidence that the kinds of chemicals that astrobiologists are hoping to see are actually there. And then it will transmit that information back to Earth. Now, Rocket Lab isn't the only company that's going to be sending a mission to Venus. We've got NASA sending 2 missions to Venus. The European Space Agency is also sending a mission to Venus. So hopefully with all of these different perspectives, we'll get a much better view on how Venus evolved, how it got so horrible, and that possible chance that there could be life there. One cool thing is that the NASA and ESA missions aren't expected to launch to Venus for many years, probably not arriving until the 2030s, while the Rocket Lab mission could be launching in 2023 and then arrive later on in that year. And so we could get this data back much sooner than the NASA and the ESA mission. It's pretty exciting. Space bubbles to fight climate change. As I'm recording this video here in Western Canada, we're experiencing another heat wave where temperatures are going up to about 35 Celsius. It's not fun. I don't like it. And more evidence of climate change all around us. Now, obviously, the best thing is for us to cut down on our carbon dioxide emissions, go back to pre-industrial levels, let the planet cool down. But let's say that we're not able to coordinate all of our activities in time and the planet continues to warm. Scientists have suggested more drastic measures, effectively terraforming Earth to be more like Earth. And that would mean potentially putting particulates up into the upper atmosphere, or maybe putting additional iron into the oceans that would help draw down carbon dioxide or block solar radiation. But these kinds of giant experiments will almost certainly have unintended consequences that we could be suffering from for decades, if not hundreds of years. So a team of researchers from MIT have proposed sending your solution to space. They propose sending giant bubbles to space that would block the light from the sun that then could be moved again once we've gotten our carbon dioxide emissions under control. By blocking just 1.5% of the sun's radiation, they figure that will cool the planet back down and buy us more time to get our emissions under control. But even that, you can imagine, has all kinds of unintended consequences. And not to mention how difficult it would be to actually create bubbles that can block more than 1% of the sun's radiation. It sounds like an enormous engineering challenge, but it's an idea anyway. Europe is considering space power. Now, we hear this every couple of years, and I don't know, like right on schedule, someone else is considering whether or not it's effective to transmit solar power from space down to the Earth. And when you think about it, it makes sense. If you can send your solar station, your solar panels to orbit, they can receive the radiation from the sun. There's no clouds, there's no weather, there's no atmosphere. You can point them right at the sun and collect the maximum amount of solar power. And then in theory, you can transmit that power back down to Earth with some other wavelength, like microwaves, and then be able to use that power. And the European Space Agency announced this week that they're going to be looking at plans for practical space power. But this idea has been studied many times in the past, and everybody who has studied it has said it's ridiculously expensive and would require like many orders of magnitude in drop in cost for rocket launches for this to become feasible. At the same time, solar power down here on Earth is just getting cheaper and cheaper and cheaper, dropping by orders of magnitude every few years. And so it's hard to believe that we'll ever reach a time when launching satellites makes the most sense for generating power. In fact, Elon Musk, who owns both a spaceship company and a solar power company, said it's one of the most ridiculous ideas that he's heard. So, he should be all in, and even he thinks it's not a great idea. And one researcher who I really like their perspective is Casey Hanmer, and he went into this in great detail on a blog post and sort of calculated where all the issues are and found that it's probably like 3 orders of magnitude, like 1,000 times more expensive to generate your power from space than it is from here on Earth. So you're probably going to hear this many times into the future, and just remember that it is incredibly expensive, probably not going to pay off. That said, there is a good reason to generate power in space, and that's when you're going to be sending power from space to space, when you're going to be trying to power a satellite or rover that's in the darkness, and you need to be able to deliver a power. And actually, I've got a great interview on that with Dr. Stephen Sweeney. We talked about all the different ways that you could transmit power from space to space, and where that could be a really effective way to power your spacecraft. So check out that interview. More evidence that the moon came from the Earth. Where did the moon come from? Now, there's been a bunch of theories to propose how we got the moon. One is that the moon was like another protoplanet that the Earth captured. A different idea is that early on, the Earth spun up and birthed the moon, which then formed into its own sphere and orbited around the Earth. But the leading theory is that at some point billions of years ago, a giant Mars-sized planet crashed into the Earth, and the debris collected into what is now the moon. Now, we've got some evidence that this is true. In fact, the Apollo astronauts brought back samples from the moon that showed that the kinds of chemistry of the rocks on the moon are related to the kinds of rocks that we have on Earth. So it's definitely pointing in the right direction. We got much better evidence from a new paper that came out this week talking about how scientists have found meteorites from the moon in Antarctica. And when they sliced open these meteorites that came from the moon, they found trace amounts of noble gases like neon and helium that perfectly match the kinds of noble gases that we have here on Earth. What happened was, billions of years ago on the moon, there was some kind of volcanic eruption, and you got magma, lava flowing out onto the surface of the moon. And then this solidified and crystallized, and the gases that were present inside the rocks inside the moon were trapped inside these little glassy pockets inside the meteorite. Then a meteorite struck the moon, blasted pieces off its surface. Some of those found their way to the Earth, and that's how scientists were able to find these meteorites and then examine them. And that original lava magma would have protected the gases from both any interactions on the moon, but also the whole process of getting from the moon to the Earth, going through the atmosphere and landing. So more evidence that the moon was once a blasted off remnant that came from the Earth. Why Betelgeuse dimmed? One of the big stories in the last couple of years was the star Betelgeuse dimming. Now, this is a red giant star. It's easy to see with your own eyes in the constellation of Orion. In fact, when Betelgeuse was dimming back in 2019, it was obvious. Like, you could see, you could go outside, look at Orion, and you could see that this star that is normally one of the brightest in the constellation was significantly dimmer than it normally is. And this was a big mystery to astronomers, and they were trying to figure out what was going on. Now, of course, we were all hoping that Betelgeuse was about to explode as a supernova. If it did, it would be the brightest supernova on record. It would be visible during the daytime. It would be amazing. But it didn't happen. And after a couple of years, Betelgeuse went back to its normal brightness. So what happened? Now, astronomers proposed a lot of ideas, but the one that seems to have stuck is that there was some kind of dust cloud that was released by Betelgeuse that then got in between us and the star and obscured it from our perspective. And now astronomers have been able to do a lot of follow-on observations from the Hubble Space Telescope and others, and they were able to trace it back to a giant coronal mass ejection. Now, the sun has these coronal mass ejections. In fact, that's how we sometimes get auroras. You get this giant blob of material blasted off from the sun, travels through space, interacts with the Earth's magnetic field, and so we can see these auroras. The ones on Betelgeuse can be 400 billion times more powerful than the ones on the sun. And so you got this gigantic coronal mass ejection blasting out this material that obscured our view to the star and made it look dimmer from our perspective. To get better information, astronomers are planning to do some follow-up observations with the James Webb Space Telescope. James Webb is ideal for looking at cooler objects, such as this cooling down material that was blasted out of a relatively cool star. So in the next couple of years, we might get more observations and get a much better answer for exactly what caused Betelgeuse to dim, what stage of its evolution is it in, and when is it finally going to explode. Thanks to Gaia, we know when the sun will die. Our sun is a main sequence star, just like most of the stars out there that we can see. And so the sun has been around for 4.5 billion years, and it is slowly converting hydrogen into helium in its core, and it's slowly heating up as it does this. After a while, it will run out of fuel in its core, it will blow it up as a red giant, and then it will blast off its outer layers, and then it will shrink down to become a white dwarf. So where along this process is the sun? Now, astronomers have figured out the evolutionary process of stars about 100 years ago. And there's a really famous diagram called the Hertzsprung-Russell diagram. And this was originally developed back in like 1905. Astronomers were able to chart the star's color and their absolute magnitude. Now, the color tells you the star's temperature. The absolute magnitude tells you the star's size. And by knowing the color and the magnitude, knowing the temperature and the size, you know how far along the stellar evolution that star is. Now, this only is for the stars that are on the main sequence, like our star. Once stars reach ridiculous sizes like Betelgeuse, they fall into another collection. They're off the main branch, and the rules are different for those other stars. But for the main sequence stars, you get this combination between color and absolute magnitude. And in that original diagram, they only had 300 stars to work with. So it's a very rough document. Now, in subsequent century, astronomers have collected information on thousands of other stars and built a much more comprehensive map of stellar evolution. But now astronomers have used Gaia, of course, like they always do, like every cool discovery in the last few years comes from Gaia, to build the most comprehensive Hertzsprung-Russell diagram that we've ever seen. They used Gaia to measure the size and color of 4 million stars within 5,000 light years of Earth. It's a ludicrous number, and built this incredibly detailed map of stellar evolution. So what does that mean for the sun? Well, when you take the sun and you put it into this map and look at the various analogs, it tells us that the sun will probably reach its maximum temperature at about the 8 billion year mark. Remember, we're at 4.6 billion right now, so a few billion years more. And it will probably die at the 11 billion year mark. So we're less than half of the way through the sun's life. Lots of time before it turns into a red giant and then dies as a white dwarf. A new way to look for exoplanets. Astronomers know of thousands of exoplanets. Most of them were discovered using the transit method, where you take the light from the star and you watch as a planet passes right in front of the star and then comes out the other side, and the light from the star dims a little bit, and you're able to tell the orbit of that planet as it's passing in front of the star. That's one way. There's another way called the radial velocity method, where astronomers measure how the light of the star changes because the gravity of the planet is pulling it back and forth from our perspective. But in both of those situations, you really need to have the planet and the star lined up with the Earth. And the vast majority of planets out there aren't going to do that, especially ones that are farther away from their star. So a new idea has been proposed that you could detect exoplanets by their magnetosphere interacting with a star. So we talked about this earlier, right? That Betelgeuse gives off these gigantic coronal mass ejections. The sun does it as well. The sun releases flares. This material flies through the solar system and interacts with the Earth's magnetosphere and causes the auroras. And those auroras are actually giving off radio emissions out into space. And so with a powerful enough radio telescope, we should be able to detect the radio emissions coming from these flares and coronal mass ejections interacting with the magnetospheres of planets. And what's amazing about this, one of the big questions that we have about life is, does life require a protective magnetosphere to shield the planet from the radiation of space? We probably wouldn't have life as we know it on Earth without the Earth's magnetosphere. And so with this technique, you would actually not only be detecting a planet, but you would be detecting a planet that is protected by a magnetosphere that could be the ideal place to search for life. Imagine if it's in the habitable zone of a star and it's giving off emissions because it's protected by a magnetosphere. It's really exciting. Now, it's probably just beyond the capability of any existing radio telescopes, but the next generation ones, like the Square Kilometre Array, could do it. A photon ring for M87. Now, we've been enjoying all these incredible images from the Event Horizon telescope for a few years now. We saw the black hole event horizon for M87. We saw the event horizon for the supermassive black hole at the heart of the Milky Way. But it's been several years and astronomers are continuing to work with these images and try to pull out more data. We saw polarized light coming from the event horizon at M87. And now scientists think they've detected the photon ring at M87 for the first time. Now, the photon ring is a region around a black hole where the gravity is so strong that light goes into orbit around the black hole as if it was like a planet going around a star. And this is pretty much the last place that you could observe anything going around a black hole. Anything beyond that, and all the light is getting absorbed into the black hole. So if true, this is really the closest that astronomers have ever gone into observing a black hole, and will allow them to test many of the other ideas proposed about gravity by Einstein and others. So research continues into looking closer and closer at black holes across the universe. You can imagine next generation telescopes being able to peer even closer or look at other black holes as well and help confirm their existence across the universe. It's really exciting, if true. The largest Webb image taken so far. Once again, we saved an image from Webb for the end. That's your reward for handling all of the other space news. So this time, you're looking at an image that is made up of 690 individual frames taken by Webb. Now, it's in a patch of sky in the Big Dipper, which is similar to where Hubble took its original deep field survey. The image covers about 6 to 8 times as much space as that original image release that we got last month when we got the first scientific images from Webb. Of course, it is full of galaxies, and it possibly contains the most distant galaxy ever seen. But honestly, at this point, I feel like almost every week we're announcing the most distant galaxy ever seen. So I think we're going to need to wait a few years to finally decide what is the farthest galaxy that Webb has ever seen. And the researchers who produced this image say they're only about halfway through their actual data gathering. So we're going to probably see even more really cool images coming out of this team. Now, if you want more information on any of these stories, the links are in the description down below. Many go to articles on the Universe Today website where we're covering all of these stories. This is, of course, just a tiny version of the much longer weekly email newsletter that I write. It goes out on Fridays, goes out to more than 50,000 people. I write every word. There's no ads. It's totally free. You should subscribe. Go to universetoday.com/newsletter. And if you would prefer an audio version of everything we do here, you can sign up for our podcast. Go to universetoday.com/podcast, or just search for Universe Today on iTunes, Spotify, or wherever you get your podcasts. Thank you to everyone who supports us on Patreon and helps us stay independent. Thanks to all the interplanetary researchers, the interstellar adventurers, and the galaxy wanderers. And a special thanks to Andrew M. Gross, who supports us at the Master of the Universe level. Your support means the universe to us. All right, those are all the stories this week. I'll see you next week.